have a present value problem. Mark receives $2,000 at the end of every month for 1 year. The payment is stopped for another 1 year. At the end of the first month from the third year, he receives $3,000 for a period of 2 years. If the interest rate is 6%, find the present value of this payment. So we want to approach this problem from two angles. First of all, we are going to create a presentation of what might have been happening. So he was receiving, this is for the first period. Then, so this is 12 months. Then for the next 12 months, there was no payment. And then finally, from the end of the next 24 months, he was receiving an amount R2. We know that R1 is 2,000. We know R2 is 3,000. And we know I is R over 12, which is 6 over 12, equals 0.5%. Or if you wish, you can write it in decimal form. So he receives R2 a total of 24 months for the next 2 years. Now, what knowledge do we have? So basically, what we can do with our problem is we could put it in two different ways. And the two different ways is that I could get the present value at this time, PV1, and also I call the present value here PV2, so that my present value will be the present value PV1 plus the PV2. So I have to do them separately because I have to discount the second batch of payment. The second set of annuities R2, I'll have to bring it until the original starting time 0 because the starting time is here. Here it is when time is equals to 0. And so that's something we want to keep in mind at present value when payment is made at the end of the month. The present value is given by 1 minus 1 plus I raised to power minus n over I times R. It will be 1 minus 1.005 raised to power minus 12 and then times 2000 divided by 0.005. And if you do the computation there, because we'll be able to know what the present value, it will give us 23,237.86413. So that it's the same formulation, 1.005 raised to power minus 24. Remember now it is for 2 years times 3,000. The interest rate doesn't change. And this will give us a figure close to 67,688.59866. Now, if I take you through the diagram again for the purpose of clarity, remember we have 1 year, then we also have another 1 year, then we have 2 years. So the PV is here, PV2 is here. So we need to discount this amount to times 0 here. because PV1 is here. So we need to discount it again. And therefore, what does that mean? That the actual figure that we have for PV2 will be equals to 67,688.59866 times 1.005 raised to power negative 24. 2 years, 1 year 2, which is negative 24, and that will give us 60,052.35468. So combining those two together to be able to get the present value, then the present value is given by, I'll start with the one that I have next to me, and then I'll add to the previous one, which was 23,237.86413. And if I do the sum of that, I'll get 83,290 plus 0.21881. And that will give us the answer to that problem that we had at the beginning.